Thermodynamics is all about the nature of energy, such how it gets used and how it changes from one form to another. Occasionally, thermodynamics involves using heat to provide works, as in the case of automobile engines, whereas energy occurs and considered as the basis of energy dynamic process. But we can see how it evolves by asking new questions. In the case of thermodynamics, of asking how real systems behave and how they differ from those ideals, but unreachable ideal limits. In order to avoid confusions, scientists discuss the thermodynamics values in reference to the system and its surrounding, in which they are separated by a boundary. Boundary must be clearly defined, so one can clearly say whether a given part of the world is in the system or in its surrounding. Moreover, there are fundamental laws of thermodynamic system, which conceptualize the effect of work, heat, and energy on a system. The first law, also known as the law of conservation of energy, states that energy can neither be created nor destroyed. Energy can only be transferred or changed from one another. It involves more kinetic potential, and it also concerns of internal energy. While we found out that this is untrue in the quantum level, but in order to understand why, we will go into the second law. The second law states that the state of entropy of the universe as an isolated system will increase over time. The second law also states that the changes in the entropy of the universe can never be negative. The third law states that the entropy of a system approaches a constant value as the temperature approaches absolute zero. This will essentially allow us to quantify the absolute amplitude of entropies. It says that when we are considering a total effect of crystalline structure at absolute zero, it will have no entropy. The laws of thermodynamics are very important because they control the interaction of everything in the universe, regardless of scales. These rules stretch across every form of science known to humankind. It has no such exceptions. Energy is conserved, regardless of the amount or type of energy. Closed systems always tend towards greater entropy, unless externally modified, whether those systems are atomic or galactic size.